Good evening, Professor Namoko and classmates. So today I'm going to present my topic on monitoring project duration and cost in a construction project by applying statistical quality control charts. For introduction, so Lipke discussed statistical distribution of several cost indices of EV or earned value and discussed a method for approximating the distribution to normal distribution in case of non-normally distributed data. So the studies are important as they try out whether normality assumption for the indices is valid. So Christensen also studied statistical distribution of cost data and reported that the data can approximately be normally distributed. Then Barazaga applied stochastic S-curves to determine forecasted project estimates. Their work included forecasting the project performance by prioritizing the actual performance of plan and by combining it with the probability of completion. Later, Barraza and Bueno introduced a probabilistic project control concept by extending the performance control limit curves to derive an acceptable forecast of final project performance. Here, the objective was to not exceed planned budget and the schedule risk levels. Neither of these two studies considered statistical monitoring of project performance during its execution. Stein also studied the importance of quality in projects, but from another point of view, that is, he studied a framework for managing quality on several specific projects. The work is more about providing a managerial framework rather than providing an analytical approach. So that's for the introduction. Now for the problem statement. So the Schedule Performance Index, or SPI, is a measure of conformance of actual progress to schedule and is usually evaluated by comparing the periodical SPI against 1. Unless SPI deviates from 1, everything seems under control. However, even short deviations may still contain warnings about current or future status of projects, which may highlight possible need for corrective actions. Besides, in a high priority project, the small variations may be more important than a project with a normal priority. However, the traditional approaches of evaluating and monitoring project progress cannot distinguish variations to this extent. So in fact, the traditional approaches have not developed accordingly. Therefore, developing appropriate approaches to evaluate and monitor EV indices and estimates such that the associated variations can also be monitored would be valuable. So currently, SPI and CPI computations, they could only monitor uh, the, the project on a certain extent. You cannot monitor very small variations. For the objective, so the aim of the study is to develop appropriate approaches in evaluating, monitoring EV indices, and estimates such that the associated variations can also be monitored. This includes applying statistical quality control charts to monitor EV indices statistically. Thus, performance and progress variations can be monitored. The most important outcome of this integrated approach is that even small variations in recorded indices of estimates can be noticed and traced back. Going into the methodology, so we have here our input is a 30-month SPI and CPI data, and the output would be we're going to turn that CPI and SPI data into statistical quality control charts, and we'll get the UCL and LCL, the upper control limit and lower control limit. So SPI is a performance measure of actual progress schedule. So SPI is measured as the ratio of the EV, or the earned value, to planned value. That is SPI's EV over PV. And CPI is a measure of budgetary conformance and the actual cost of work performed. And that is the most useful index indicating the cumulative cost efficiency of a project. CPI is the ratio of EV to actual cost, that is CPI is equal to EV over AC. So these two are important formulas. So from 30 different projects, we're going to get their 30-month SPI and CPI data. So that's 30 samples. Then the output that you're going to apply statistical quality control charts into it. Now for the results, so through several indices such as Scheduled Performance Index and Cost Performance Index, earned value techniques quite capable of monitoring and analyzing project performance. There are a lot of literature that says so. For example, the Project Management Book of Knowledge, or the PM book, utilizes EV to monitor and analyze performance in a project. However, the application of statistical quality control charts allow us to look into very small trends and details. So it's not enough that we only measure a project as a whole, because even small variations, they could tell us a lot. So this is really important in construction projects. So we should not only limit ourselves in measuring um, the large scope of the project, it's also important to look into the details so that when we implement projects and monitor them, we could see the variations even at the tiniest details. So that's the importance of this study. I'm architect Adolf Vincent Ibigor, a DTE 635 student under Professor Consorcio Namoco. So this is my report on monitoring project duration and costs in a construction project by applying statistical quality control charts. Thank you, and I hope that you learned something from my presentation.